Saturn is weirder than you think. We all know this planet as the crown jewel of the solar system, with its spectacular rings and bright golden clouds. But behind that veil, there is a powerful and destructive force out there that we can't see from the Earth. That's why NASA sent a probe in the late 90s named Cassini. It was a bold mission with a shocking end, and what it found will change your view of Saturn forever. The first thing you need to know is that the rings of Saturn are disappearing. On the cosmic timeline, Saturn's rings are pretty young. They're believed to have formed around 100 million years ago, and they're already beginning to vanish from existence. Here's a scenario for you. Before Saturn had rings, it had an extra moon. It was relatively small, about 400 kilometers in diameter, but it would have been an incredibly dense ball of solid ice. And this moon was orbiting very close to Saturn, too close, and over a very long period was slowly pulled in closer and closer to the gas giant until it crossed an invisible line known as the Roche limit. This is the point where the gravity of Saturn begins to overpower the gravity of the moon. Think of it like a tug of war between two gravity wells. The ice moon is trying to hold itself together, but the pull of Saturn is just too strong. So what happens when you cross the Roche limit is the gravity of the larger body tears the smaller body apart. This causes the ice moon to fracture and disintegrate into tiny pieces, releasing about 17,000 trillion tons of ice into the orbit of Saturn. Now we have all of these chunks swirling around the planet, colliding and breaking down into even smaller pieces, getting pulverized into dust and being pushed out into a thin disk by the rotational force of Saturn. So to get those iconic rings, Saturn had to destroy a moon and wear its corpse like a trophy. Most of the debris left behind in the rings today is somewhere between 1 centimeter and 1 meter in diameter, but the full range covers everything from microscopic dust particles to boulders that are tens of meters in diameter. The process that created the rings is essentially the same force of nature that creates solar systems and galaxies, just on a much smaller scale and a much faster timeline. It would have only taken a few days for the disk of ice around Saturn to take shape. What's really interesting here is the way that a flat disk was transformed into the distinct ring shape that we all know so well today. You see, inside that field of debris from the collapsed moon, there were still a handful of bigger chunks that survived the battle with Saturn, and they got caught up in this big swirling disk as well. Over time, the chunks settle into their own orbit, and they start circling around the disk, collecting all of these little dust particles and chunks of ice as they go, and essentially carving out their own roadway through the disk. We call these shepherd moons, and the paths they cut through the original disk are what created the distinct pattern of rings around Saturn. The size of these rings is incredible. They stretch over 280,000 kilometers across, which is enough to span most of the distance between the Earth and the moon. But they are also incredibly thin, with an average depth of just 10 meters, or about the height of a 3-story apartment building. If you were to approach Saturn from a side-on direction, the rings would be almost invisible. While they might look flat and uniform from a distance, when the rings are investigated close up, they reveal a much more complex 3-dimensional structure. Some rings are actually shaped into waves by competing gravity from nearby shepherd moons. Other rings have formed mountain ranges of debris with peaks reaching up to 200 meters tall. We are able to see all of this thanks to a spacecraft named Cassini, which was easily one of the most ambitious planetary exploration missions ever launched. The probe was a joint effort between NASA, the European Space Agency, and the Italian Space Agency. It was launched in 1997, and after a 7-year journey through deep space, ended up spending 13 more years observing Saturn and its ring system. Most of what we know today about Saturn comes from the Cassini mission, which actually flew through the rings themselves and eventually into the planet's atmosphere, but we'll get there in a minute. It's pretty incredible. And maybe the most amazing thing of all is just how lucky we are as people to have been alive to see this, because the same force that created Saturn's rings are also slowly destroying them. Just like the original moon that started it all, the debris field is being pulled down by the gravity of the giant planet. That's one source of ring destruction. but the shepherd moons are doing their part as well. Some of these small moons have enough of their own gravity to pull in dust and debris like a cosmic Roomba, growing heavier and increasing their force of attraction. Others might be too small for gravity, but they still manage to collect dust just by running into it, like a snowball rolling down a hill. Any dust that the moons aren't able to collect, they tend to push away, either down into the gravity of Saturn or outward into space. The longer this process continues, the thinner the rings will become until eventually they are gone forever, or at least until the shepherds start falling down into the planet's gravity to break up and begin the game all over again. Now, you might not know that the biggest ring of Saturn is actually almost invisible. It's like a giant blue halo that extends out around the planet and can only be seen when it catches the light of the sun at a very specific angle. This ring did not come from a destroyed moon. It's actually being created right now by a very alive moon called Enceladus. We've known for a long time now that Enceladus was a big ball of ice orbiting Saturn just outside of the main ring system. But when NASA's Cassini probe arrived to investigate Saturn in 2004, it quickly noticed something weird about the moon. Radio waves coming from Enceladus were very inconsistent, not what you'd expect to see from a frozen ball of ice. So the decision was made to steer the probe over in that direction and see what was going on. And this is what Cassini saw: massive geysers of water vapor erupting from the south pole of Enceladus. So this blue halo around Saturn is actually a ring of water trailing out of a moon. The thing about Saturn is that there's actually a lot more going on out here than just a spectacular set of rings. If we zoom in close to the planet itself, we're going to find some even deeper mysteries. Stuff like this: Saturn's North Pole, which is shaped into a nearly perfect hexagon. It's actually a storm system that is wider than the Earth and was first spotted by the Voyager 1 probe back in the 1980s, but was never closely examined until the Cassini spacecraft arrived in 2013. And this is one of the strangest things in our solar system. Remember that there is no surface on a planet like this. It's just a thick shell of gas that forms into dense clouds. Inside those clouds are raging storms with thunder and lightning and incredibly powerful winds. Saturn actually has the second fastest wind speed in the solar system, just behind Neptune, with gusts reaching up to 1,800 kilometers per hour. You can see that reflected in the thick bands of clouds that wrap around the planet and spin at incredible speed, sometimes in opposite directions to each other. Then right at the very top of the planet is this one powerful hurricane that's captured hundreds of smaller storms in its orbit. And surrounding it all is a polar jet stream that contains the entire system and forms a six-sided barrier that separates the polar vortex from the rest of the planet. The crazy thing is that we're not really sure why this happens. Every other natural shape in the solar system tends to be round, except this one. Scientists on Earth have tried to replicate the hexagon storm using water tanks, and while certain currents are able to produce the shape for a short time, the experiment has never succeeded at making a stable hexagon like what we observe on Saturn. The leading theory right now is that the storm we see in the cloud layer is being driven by something massive deep within the layers of Saturn's atmosphere. An important thing to remember with gas giant planets is that they're not actually made entirely of gas, but they're not solid either. They're more like a gradient of different states of matter, and when you start to dive into it, some strange things begin to happen. The composition of Saturn is pretty simple. It's roughly 3/4 hydrogen and 1/4 helium. This means that by volume, Saturn is incredibly light for its size. It's actually so light that it would be the only planet in our solar system able to float in water, if you could somehow throw the planet into a cosmic bathtub. But Saturn is still gigantic, so that provides enough mass to create an incredibly powerful well of gravity that pulls hydrogen down towards the center and squeezes it to the point where gas becomes liquid. Then below that ocean of liquid hydrogen, there should be an incredibly dense core of rock and metal. All of that pressure actually makes the core of Saturn incredibly hot, reaching up to 11,000 degrees Celsius, more than twice as hot as the surface of the sun. Now, going back to our hexagon, it's possible that the massive storm we see from space is being driven by a powerful vortex down in the liquid hydrogen layer of the planet. So there's something like a big whirlpool over the North Pole. We're not sure why that would exist in the first place, but the energy of that rotation is generating clusters of storms that move up through the layers of atmosphere and kind of merge into one massive geometric shape. It would be impossible to replicate these conditions in an experiment because of that incredibly hot, dense, high-pressure liquid on the bottom of the storm and the ice-cold vacuum of space on the top of the storm. There's also the color of Saturn's hexagon. You'll typically see it looking blue in images captured by Cassini in 2013, but in 2017, it appeared in a gold tone. So it's believed that the color changes with the planet's seasons and exposure to sunlight, blue in the winter and gold in the summer. Unfortunately, we never got a chance to see if the hexagon turned blue again because 2017 also marked the end of the Cassini probe's mission, but it went out in a pretty spectacular fashion. After 13 years of maneuvering through the space around Saturn, the probe was running out of fuel. So, NASA operators end up with two options. They can go into conservation mode and try to keep the probe operating, but not really doing anything of particular interest, or option 2, go down in a blaze of glory. They picked option 2, so the decision was made that they were going to use what little fuel Cassini had left to dive down into the planet itself. They knew that the probe wouldn't last long before being caught by the wind and spun out of control, at which point it would be very quickly pulled down and crushed by the immense gravity of the giant planet. So to extract the maximum data out of this final mission, they plotted out a series of orbits that would gradually bring the probe closer and closer until it eventually hit a point of no return. The first group of orbits took Cassini down through the outer edge of the rings that just grazed the swirling mass of crushed ice, completing 20 flybys in total. After that, Cassini changed course for its grand finale, diving down between the planet and inner rings. With each pass, Cassini got closer and closer to the atmosphere until, on the 22nd orbit, this happened. The probe's maneuvering thrusters were overpowered by the wind in the upper cloud layer. Once the vehicle begins to spin out, it loses direct connection with Earth, and the monitors at NASA go dead. The probe would have tumbled down for a while before getting torn into pieces that would eventually be crushed and then melted down in the planet's lower atmosphere. And unfortunately, those final images from Cassini are going to be the last we see of Saturn for a long time. There are proposed mission concepts out there to return to the rings and atmosphere of Saturn at some point in the 21st century, but none of these have materialized into a concrete plan as of yet. In the meantime, we still have mountains of data gathered by Cassini that is still being read through and interpreted by some of the smartest people on Earth. The investigation is far from over, and the real mysteries are still to be revealed. And this is just one of many probes sent out, all searching for answers to some of the solar system's greatest mysteries, like what is hiding on the surface of Venus, or what lies beneath the eye of Jupiter.